You have an exam coming up, and you will be given a formula sheet on this exam. I've posted the formula sheet for you to be able to glance through the formulas. This video is going to walk you through each of the formulas and give you some pages in the notes that you can refer to and examples of when to use each formula. The first formula that you will be given is for the median. There are two formulas, one for when you have an even amount of participants and another for when you have an odd amount of participants. You can find examples on how to use this formula on pages 59 through 62 in your notes. Remember, if you're finding the median using a scatter plot, to watch out for the leaf units. The next formula that you will be given is a formula for the slope and a formula for the y-intercept. You could take both of these values and put them together to get your regression line, y hat equals mx plus b. You will not be given the y hat equals mx plus b formula. You will also not be given the residual formula. That's y hat. That is y minus y hat. You can find examples for these formulas on pages 93 through 95 in your notes. The next two formulas are for the normal distribution and the sampling distribution of the sample mean. Examples for the normal distribution are on pages 110 through 115, (123) and 126 in your notes. Examples for the sampling distribution of the sample mean are on pages 120 through 126 in your notes. This example will help you identify when to use each of the formulas. The Kimber Custom Shop produces the solo CDP. We have read that the gun weighs 17 ounces, but there will be variability in the weight. It is a random variable. The distribution of weights for these handguns is approximately normal, with a mean of 18 ounces and a standard deviation of 1.5 ounces. We can use that to write the notation for the normal distribution. X is distributed as a normal random variable with a mean of 18 and a standard deviation of 1.5. You'll know to use these distributions because they're for continuous variables. This example has to do with weight. So weight is a continuous random variable. You could also take this information and use it to create the sampling distribution of the sample mean. X bar is normal, 18, and 1.5 divided by the square root of. And then we go in and we read in the problems, Part A and Part B. Part A asks what's the probability that one randomly selected solo CDP weighs more than 17 ounces, versus Part B, which asks about the average of 5. So we know that the N here is 5. Whenever a problem talks about 1 or A, you use the normal distribution. Whenever the problem talks about a group, so a group of 5, or an average, you use the sampling distribution of the sample mean. Either way, both problems get solved using the same steps. Step 1, write in terms of whatever letter is at the beginning of the tilde sign. So here we would be looking at the probability that X, and here we would, in the second one, we'd be looking at the probability that X bar is more than 17, is more than 17. Remember, the table works in terms of less than. Step 2, whenever you see normal, that means switch to a Z. You do that by subtract, divide. Same thing here. Step 2, normal means go to a Z by subtracting the first and dividing the second. The last thing you do is you look in the table for these z values. So step 3, you'll go to the table. Now I'm not working this example out in detail. I'm more trying to indicate to you when to use each formula on the formula sheet. If you want to see the example worked out in detail, go to the pages I referred you to in the notes. The next formula on the formula sheet is for the Poisson distribution. You can find examples of this on pages 129 through 134 in the notes. The Poisson distribution is for discrete, countable data. An example of when to use the Poisson distribution would be looking at the births in a hospital, which occur randomly at an average rate of 1.8 births per hour. The way we know that this is Poisson is that there's no upper limit. So we don't know at what point babies will quit being born. But we do know there's a lower limit of 0. The least amount that could be born are 0, which means that there's a skewed right shape. That's a big indicator of the Poisson distribution. The second reason we know that this is Poisson is the outcomes are not yes or no. The outcomes are a count. Either there's 0 babies born, 1, 2, 3, all the way up to however many babies are going to be born in a given hour. You can contrast this with the binomial distribution, which is covered on pages 136 through 142, and pages 152 and 155 in the notes. With the binomial distribution, there's only 2 outcomes. Either a cow tests positive or negative. Either a child is bitten or not bitten by a dog. The second indicator is that there's a fixed sample size. You know there's exactly 20 cows, or you know that there's 30 children that we looked at. So that's the biggest difference between the binomial and Poisson. There's an upper limit. There's a constant probability of success, 60% for being bitten by a dog, 1% for having trig. That gives you the notation. To actually find probabilities, you'll plug those values into the formula. Remember, if you're finding the probability that x equals a number, that would be a binomial PDF command call. And if you're finding the probability that x is less than or equal to a number, that's a CDF command call in the calculator. There's also an explanation of the C choose X portion of, or the N choose X portion of this formula. You won't need to use this on the test, it's just there for your reference. The binomial formula itself can be difficult to work out if you don't have a calculator. So statisticians like to come up with options to avoid using the binomial formula. There's 3 options. If n times p is smaller than 7, you can use the Poisson distribution. The second option is if n times p is greater than or equal to 10, you can use the normal distribution. The third option you don't have to consider what number n times p multiply to. It works in a different way, and that would be the sampling distribution of the sample proportion. So let's go talk about these 3 methods on the next page. In this setting, we said that x was binomial, n is 20, and p is 0.01. If you multiply n times p, that will give you an average, and that's 0.2. Because 0.2 is smaller than 7, you would use the Poisson distribution and say that x is also distributed as a Poisson variable with average 0.2, and then work out your formula from there. You can find more details on how to work out problems like this on pages 143 through 144 in the notes. The other scenario would be that when you multiply n times p, and looking in this example, p is 0.6, there's a 60% chance of being bitten, and the sample size is 30. You get a value that's bigger than 10. Here, n times p is 18. In that case, you could say that x is normal 18, and square root of 30 times 0.6 times 0.4 gives you a standard deviation of 2.68. And then you could work this out using the normal distribution. Step 1 would be to write in terms of x. Step 2 would be to switch to a z, because anytime you see normal, you switch to a z. You do that by subtracting the first number and dividing the second number. And step 3 would be to look in the table. There's examples of how to do this on pages 145 through 147 in your notes. Or the second statement that you could make would be that p hat is normal, and p is 0.6, and the standard error is 0.6 times 0.4 over 30. And then from here you could again work out your steps. Step 1, write in terms of p hat. Step 2, normal means go to a z by subtracting the first, dividing the second, and then looking in the table. You can find an example of how to do this on pages 149 to 156 in the notes. One of the questions students have is, how do you know how to work out how to approach the problem? When you test, I will specifically say use normal approximation to the binomial if I want you to use this formula. You will use the binomial distribution if you're dealing with counts. And you will use the sampling distribution of the sample proportion if you're dealing with percents. So if I ask you the question, what's the chances that 3 or fewer people are bitten or attacked by dogs, that's a count. And that's the probability that x is less than or equal to 3. If I ask you what's the chances that 10%, less than 10%, of people bitten or attacked by dogs or children, that would be the probability that p hat is less than or equal to 0.1, because it has a percent. Instead of talking about 3 children, you're talking about 3 out of 30, which would be the 10%. So again, your keywords are count versus a percent. One of the other questions that people have is, how do you know whether to use the XZ table steps, the X bar Z table steps, or the P hat Z table steps? One of the important distinctions to notice about this is that it's for discrete data, meaning that it's countable. So we count the number of people that are bitten or attacked by dogs. You know you're starting with a binomial distribution. If you compare that with the one earlier where we were talking about weight, weight is measured, not counted. So that's a big distinction in those two. The next formula is for a confidence interval for one proportion. This is on pages 159 through 168 in the notes, and pages 170 through 181 in the notes. Keywords that would tell you to use this formula are the word proportion and then confidence interval. The formula for the test statistic for a hypothesis test for one proportion. Examples can be found on pages 175 through 181 in the notes. And keywords that would tell you to use this formula. Things like percent tell you to use something involving a proportion. And then again, percent. And that's most of the keywords I'm finding in this example, but it also could have directly said the word proportion. The last two formulas on the formula sheet have to do with averages. The confidence interval for one mean is covered on pages 190 through 198 and 202 through 203 in the notes. Keywords that would tell you to use this formula are words like average or mean. Here it says find the confidence interval for the mean number of times, so you know to use this formula. Hypothesis testing when a test statistic is required is covered on pages 204 through 207 in the notes. Keywords that would tell you to use this formula are things like average. You'll also be given a lot of information about standard deviations and averages in these problems. This is the end of the explanation of the formulas that you'll find on the formula sheet for the exam. I hope this helps.